How's it going? Welcome back, everybody. Let me just dial this music back a little bit. RH2, how's it going? So, I think we have some new people in here. Ooh, Ren LLC, how's it going? Daul. So it looks like someone was nice enough to kind of spread this on Reddit. So we got a bunch of new followers, some subscribers, some new people in the chat. Jabraham, how's it going? So yeah, this is a good place. I don't know necessarily for if you've never used Houdini before, but just I try to do a good job illustrating just like workflow and even like artistic reasonings why I'm doing stuff. So it should be pretty helpful even if you're not that technically like savvy or whatever. But if you are like super new to Houdini, there's a bunch of resources. It's like the CG Wiki for sure is the best one, I would say, just as like kind of a manual. You just do CG Wiki, just Google that. So this guy, Matt Estella, he's worked at Animal Logic, and he was also an instructor, I think, at the Animal Logic Academy. So if you just go to like Houdini Getting Started or whatever, he does a good job kind of breaking it down for the paths to take and stuff like that. Yes, the Vex snippet page. Thank you. So I'm actually working on redoing that and porting it over to my new website. It's not ready fully yet. But I also added like a restreaming thing or whatever. So if you go to johncoons.com/live, I've like embedded my Twitch feed or whatever in there. So if you're not a fan of the Twitch experience or whatever, you could just go here and you still have the chat and everything like that. Yeah, and then I'm working on updating, like porting over that Vex cheat sheet, adding some other stuff here, other useful resources and tips and stuff like that. So just, I don't know, make a bookmark, or if you prefer this light user interface over the Twitch kind of busier, I don't know, thing or whatever, you could just go here to watch in the future. I think that was everything. I'm trying to think if there's anything else I wanted to talk about before getting. So I'm thinking about doing some like offline tutorials for more of beginners, like entryway in or whatever to Houdini. But I don't know when I'll have those ready yet. But hoping that will be like a better thing for people to review or whatever, get up to speed, I guess, with everyone else. So close some of this stuff. Yes, I'll just put this in the chat. People want that link. It's a super good resource, just even like downloading Houdini, it's free, the apprentice version or whatever, and then videos to watch, and he has a good compilation of other. So these are all his tutorials, I believe. And then there's also, I would say, like Rohan Dalby. So he has a bunch of ones that are free. He also has some paid ones, but he has some pretty good ones for beginners as well. Let me see. Somewhere he had like an intro. I don't know if he took it. Sometimes he takes down his this maybe this one I'm thinking of. He had one that broke everything down pretty good as like a intro just for people getting started with Houdini, even going over the user interface and stuff like that. Maybe this one.
Well, that's enough of that dramatic intro. Well, I've actually got a really great video for you guys today.
I'm not sure. But yeah, so today we're going to be trying to recreate some of this style of effect from the PlayStation 5 launch trailer. Attributes act as a form to categorize data. Just leave this going, I guess. Data on your geometry, but I'm using an attribute to categorize data on my geometry to then do something to it, like adding noise to effect. Yeah, so attributes are pretty abstract concept, or it's kind of hard to wrap your head around them as you're using Houdini for the first time ever, I guess. So there's different, I don't know, like maybe a good way to think about it. Yeah, I'm guessing that this was Zeskov, Maxim. If not, like they just kind of ripped off his entire style one-to-one, like not even just the black grains with blue illumination, but like the white room, the camera angles and framing. Like if it wasn't his work, then he should hire a good lawyer or something. But yeah, attributes, they it's very hard to, I would say, like conceptualize for someone at the start. It's kind of like if you're making like a vehicle or something like that, you might have certain attributes that's like the year the car was made, the model of car, like you would have a 2004 Ford Prius or something like that. So those might be like detail attributes that you would put on your geometry. That's just like a description about everything. And then you might have some more like specific attributes for the tires, what kind of tires they are, if they're like slick tires, racing tires, all-weather tires, if you have chains on the tires for going through snow or something like that. You might have the different kits and interior options and stuff. And then like even more specific options might be like materials of the steering wheel, like leather or whatever. So it's just different, like you're narrowing or expanding the scope of like what you're talking about. But attributes, they not only, like they're used everywhere, not only just to categorize your geometry. Like with the racing tires and stuff like that I was talking about, it's kind of like, could be physical properties as well. Like it could be the friction, it could be the mass, it could be those kinds of things. You can definitely use it to drive noise. I think I'm not sure which tutorial it is, but like using attributes as a mask, like compositing or whatever, it's a pretty common workflow where you would fade like a alpha channel or whatever to say only apply this force, or transition the material properties of lighting and shading between like blending materials in the shader. All that stuff is knowing attributes is like the most powerful aspect of Houdini, I would say. The transition to PS5 from particles is a bit off. Yeah, I don't know about the entire design of the PS5. I would say is a bit off. It's like just stop watching this at 1 minute or something. Yeah, I mean, so attributes exist in all the other 3D softwares, but they just aren't like as exposed, I would say, in terms of working with them and managing them and stuff like that. If you think, not sure what the best kind of example is. I mean, if you think about like having UV attributes on your mesh, if you come from other 3D softwares, like it's kind of like an extension of UV attributes where you can just keep adding like more and more channels of UV things and assigning them to different parts of the geometry and everything like that. It's a little bit beyond the scope of this. What we might do is like even the attributes, you might see them driving color. You could have that not only driving the color, but like the brighter ones could then also have like an anti-gravity effect, or like you just have a lot more control over everything using attributes. So it's like the best way to work, or I don't know. It's the main reason I'm using Houdini, I would say. So we'll get kind of just started setting stuff up here. So I'm using this Linux stuff. If people are interested in the specs or operating system, whatever, it's just in my Twitch panels beneath the stream and all of that. Yeah, so let me just kind of continue to talk about this a little bit. So you see there's like different patterns here that are kind of referential to the buttons on the controller. So there's like the square, box, and then there's triangle, circle, and X. So there's like different ways that they're kind of blending or morphing into those materials to get those different shapes. So we'll just kind of start with setting that kind of stuff up and maybe do a little bit more of this abstract kind of stuff at the end, just like waviness and wonkiness. I think this ending is pretty transition to the hardware is pretty bad, Belk and Sergey. It's like you can kind of tell very obviously they just did a crossfade in After Effects or whatever compositing thing they were doing. Like if they actually, I don't know why they didn't, they must have changed the design or something at the last minute and they didn't have time to do another simulation or something. But yeah, it would be a lot cooler if these particles like seeped into these little grooves and like the illumination spilled out or whatever like that. But I don't know if like the industrial designers were changing the hardware at the last minute or what, but yeah, it's definitely the weakest part of that spot, I think. Yeah, I don't know. It's hard to know. Usually, like working on product reveals and stuff like this, there's so many moving parts between the industrial designers, like the engineers that actually have to like figure out. You have to like source plastic parts. You have to know like what kind of supply lines you have access to, and like I don't know, all that stuff can change and influence things very drastically. And then visuals are like the last thing that they care about, where it's just like to all the people in the boardroom at Sony and stuff, they would never probably notice that or take any issue. They'd just be like, yeah, it looks good. All right, what do we do now? So how do I use Houdini in my workflow? I don't do a ton of modeling in terms of like box modeling and stuff like that. Someone said I was good. So I don't know about my, I need to make an about me or something like that, but I've always been working as like visual effects. So that's like past the modeling standpoint, it's doing like spells or tornadoes, lightnings, electricity, like abstract, like gaseous phenomena that you can't really represent with polygons. So you need to use particles. This is kind of like this here. So you have like a very amorphous form that can transition or go into any like shape you want it to, whereas doing like hard surface modeling or geometry is a lot more, I don't know, like engineering or architecture or like drafting or things like that. So I don't know if Houdini is the best for it. They've made improvements and things, but it's not anything that I've really specialized in. I've gotten more into kind of a generalist role somewhat in the last like 2 or 3 years. So I was working at Apple like 2 years ago and doing kind of their marketing and advertising content. So that kind of stuff was very generalist. You're just kind of making quick mock-ups and ideas and stuff like that. Is still pretty effects based because it's like using particles and things like that still. And then also I was teaching Houdini at the Academy of Art in San Francisco. So it's like, that was like their intro to Houdini course. I did a destruction course and then like effects in Houdini. So it was a good, I don't know, I have a good amount of experience, like both on the high end of effects and then just like introductory and for people getting started. So what I'm gonna do with these particles here is like start to build a collider that we're gonna use to kind of force the particles to adhere to a certain shape. So you see this, it almost looks like a terrain or a mountain or something like that. So we'll start to model out or like build out geometry or some representation of this kind of invisible object or invisible collider that that looks like the camera is kind of looking through right now. Lakuku, good to see you again. Did you just get that snippet? So it's just kind of remaking or trying out, seeing how we could approach doing an effect like that, the grains in that PS5 reveal. So with this scatter, like sometimes I'll turn off relax, so you just get a more random distribution. This thing here will just try to run iterations to evenly space them. Or the other option is just like do one random pattern. And then instead of having these lay on the shell or the surface of my box, I want them inside of it. So I usually do the VDB from polygons. VDB is a newer volumetric format. You can use it, you can exchange it with other software packages and things like that, so it's pretty good to know and learn and stuff like that. And then instead of distance, you just do fog VDB. So your big difference is like, this is kind of a mask. It's like saying fill things with density, and then distance is still kind of a surface-based representation where it's trying to still just represent the actual shell of the shape, where this is saying like just give me the region that's the interior essentially. So then if I scatter, all of my points are now inside of them. Then I'm going to do the steps that I usually do to make a Voronoi fracture. I do tetrahedralize. It's a hard thing to say. With the connected polylines. And then this is what you can use for the Voronoi split. And then this, I've just wired it up a bit wrong. So we need the geometry that you're going to fracture, and then the cutting polylines in this input. You can do this like Voronoi fracture bigger tool, but I find that it's just like a bit slower to operate. And then I don't know, I'm not a big fan of like all these extra features and stuff. So I usually default, it's like one more step just to add this tetrahedralize. So I usually do this. And then if we can inspect our fracture, if we do the exploded view, we can see that we've just fractured it like it's a shell. There's no actual chunks or volume to these pieces. That's not exactly what I'm after. So if we just go to this, we can tell it to create an interior surface. It's kind of hard to tell, but there is stuff there. Sometimes if you switch to this background to light mode, you could tell a little bit easier. And that's just because my box is being created with normals, and then the new fractured surfaces don't have normals. So it's a little bit weird with Houdini. You'll hear people like talking about this low level stuff like normals and things that you might not have touched or messed around with that much with other 3D software. So other 3D software takes like a lot of that out of your hands and will just do it without telling you. But Houdini, sometimes some of the like underworkings of computer graphics is a little too in your face, and you have to deal with it too much or whatever. But that's just because there's very like specific reasons why you would be changing some of this stuff. So once we assign normals, the viewport will shade it and everything like that. So now we have our interior geometry. We've exploded it just to visualize or whatever. Then what I'm gonna do here is just do a split. And then I'm gonna try to just split by the position. So this is kind of like attributes, Mr. Who was it? I'm that guy, Brando. He was asking about attributes earlier. So this is like one of the first things you can do with attributes, which is really useful, is just directly reference them in the group sections and then use them to partition or like influence all of the operations that these other nodes are doing. So if I do at p.y is greater than 0, this is like a quick expression kind of. I just have to tell it that I'm using like a point attribute to make the group. And what this does is just says basically split things by the y position if it's larger or less than 0. So with this split node, you get two different inputs or like two different results. So basically we're changing or splitting out our geometry just based off of the y position and if it's above or below 0. Yeah, the group field can be a little bit, I tried to work without, I've done things where I use wrangles way too much and then it just gets super confusing for other people to pick up and use sometimes. But if you know wrangles well, wrangle is super good. It's very like efficient and stuff like that. So this group, there is like a reference page that you just search for group syntax with Houdini. So this page is kind of hard to find, but down here you can find this little reference that's it's like not necessarily HScript and it's not necessarily Vex, but it looks somewhat similar to it. So it's a little bit misleading. But if you can even use intrinsic attributes, which is pretty nice. So you can do like group delete by size or things like that. I think if you go to just geometry attributes, there's a section on that as well. But basically, what these are doing is it's creating like an ad hoc group out of your little expression or whatever. So like on the fly, it will make a temporary grouping just based off of this little brief code or whatever. So I'm just splitting it based off of the Y position, but you see that there's like some points that like are sitting by themselves or whatever. Like it might be a bit of a problem. We also see some insides of some of these shapes. And I want to, instead of doing this, like cutting the points, I want to cut by connected geometry. So if I just do assemble up here, what I can do is turn this to create packed geometry. And what this does is, it's a little advanced, but it's like a trick to basically go from all of these points, all of these individual polygons. If I look in wireframe view and then turn on my points, right here you can see we have points at the edges, points all around the border of my chunk. And then when this split looks at them, it's splitting based off of the positions of all the corner points and everything about the geometry. If I assemble it and turn on create packed geometry like that, what this one is doing, looks like it's a little, is basically it will represent all of these with a single point at the center of all of these chunks. So packed geometry is, you could use it for a lot of different things, but it's basically like turning or representing each individual like piece or chunk of the geometry into its own little like object that you can't modify it. So if I do that step and then look at the results, now we have, we're splitting based off of like the centroids or the centers of each of those chunks. And we don't have access to the underlying geometry. So when it splits it, it will give us like, you're kind of splitting open a mineral or something like that. So if we just compare these two, this one we're cutting like actual modifying the geometry and the connectivity of it. This one we're just deleting based off of like centroid and objects and stuff. It's a bit of a hack, but it's a useful trick sometimes. And then if you'll see here that like once the geometry is packed, I can't edit it. So if I try to grab individual points, I can't do that. I couldn't like move this vertice somewhere. So if you just want access and you want the geometry to go back to how it was, you can unpack. So now I could get like those corner points or stuff like that. And if I wanted to, could move them around. It's like that, and then I'm doing the edit SOP and everything. So that's basically why I'm assembling, splitting, and then unpacking. Is basically just doing these two steps to get a result that I want out of this split node that's a little bit more unorthodox or whatever. So now we're not like disturbing the actual, we don't have any open faces or open trunks or stuff like that. I thought the PS5 stuff def looked like some whirly noise displacement of the particles. But maybe you can get there with the Voronoi Geo as well. Yeah, so there's different ways to approach all of this. This is just how I'm starting off, but we'll go through other stuff by the end of it. Whirly can be somewhat similar to Voronoi as well, like depending on, I don't know. There's different like methods of distancing, of measuring the distance to all that stuff. Like there's the Manhattan Voronoi or Whirly, and then there's the like Chevy Chevivs or whatever that one is. That's like a lot more cyber looking or whatever. So now we have a top and a bottom. And then when you're doing simulations, like you usually want to pay attention to scene scale and stuff like that. So I'm just going to put down the test geometry Tommy. This is a good guy to reference. I know that he's like around 6 feet tall, like 5'8" or something like that. If you do the metric system, you can just look at the middle mouse like information. You just hit the middle mouse button on the node and you can see his size is like 1.78 meters. So that's his exact height or whatever in the metric system. Then if we look at this reveal, you kind of see that there's lights. It's kind of hard to get an exact sense of the scale of everything. Because there's no like doorknobs or human features or anything like that, but I don't know, I would say that this is like a 2-story building or a 3-story building or something, somewhere around that, like some weird gallery art space. So if I just do a transform, maybe I'll do it before we cut everything in half, just so that it's applying to both outputs of the split. I could make this, maybe this is like the size of a 2 stories tall or whatever. Somewhere around that I might come back and change it, but just to get things situated a little bit more in a real world. Because like, basically you might think that this is pretty abstract, but like the speed that all of this stuff rolls around at and moves at gives it the sense of scale. Where if these waves were like really rippling, like pretty quick, you might think you were like shaking these grains in a little hourglass or something like that. And the fact that they're moving slower kind of leads you to believe that the scale of them is a lot bigger or whatever. But you can find that some of that stuff is pretty interesting if you look up when they were using miniatures for like VFX. So they would film like miniature building getting blown up or something. And then they'll just slow it down. They have like actual rates or whatever that they apply like based off of the scale of the model to make it look like it's a lot bigger or whatever. So we have the top over here and then the bottom below it. What I'm gonna do is use one of these as a collision for our simulation, and then one of these as a source or to fill it with grains. So there's different Right now there's different grains in Houdini. There's the grain source that uses just the pop network with the grain solver, and then there's the vellum grains. So we could probably even, sometimes when I'm testing out techniques and stuff, I'll like exhaust all my options. You want to go with vellum? We'd start with vellum. So usually I'll like try something using a couple different solvers and just see which one performs better, because it's usually very hard to know what's best without actually, like, at least, especially if you're beginning, like if you're starting out, it makes sense to try a lot of different things. Use grains over vellum. Isn't grains always slower? We could test it and measure that. I think there's some differences. To me, I would say that the vellum grains are much better for like physical situations, like if you're modeling mud or dirt or powder or stuff like that, that you want it to look very like physically based. This is better. But I think grains still might be pretty good for some more motion graphics, like abstract based stuff. Like it might be it's a little bit more of a hack where like you can get away with more, you're not as worried about like the collisions and the physical properties being as accurate, if that makes sense. So we get started with these vellum grains. So you just plug it in. The one thing you have to just check is to create points from volume. So now that's like actually saying fill my shape with grains. Sometimes I'm not a big fan of this sprite material. Like it's not these things aren't real spheres, they're just little pictures that are being stamped on, like sprites. If you're a gamer, if you play like Sega Genesis or whatever, this is basically what it is. It's like a little character sprite that they put on. So it's always going to have these lighting things, and it won't actually like respond to any lights I put in my scene. So I usually turn that off, and then if I want it to actually look the size, you can either do the D key with geometry, switch to disks, and this will adhere to the size. Or you can actually like copy sphere primitives onto it, and it's still, the viewport in Houdini is pretty nice. Like you can handle a lot of geometry pretty quickly with it. So also talking about attributes, people were asking about that earlier. Depending on the desktop you have, like you sometimes want to expose this geometry spreadsheet. It's kind of like an Excel document to keep track of what attributes are on your geometry. I usually hide it because I've been using things enough to like know what's going on and what's adding what. But if you're getting started with, especially getting started doing simulations, I would say it's a good idea to always have this spreadsheet open or be mindful of things. So like sometimes what I do if I'm not using this, I'll just middle mouse on things a lot. So I can see right here we have a point attribute, and then we have the name attribute. So the name, another thing you can do that's pretty useful is like show node information and click on these things, and it will give you a very quick visualization of like what these attributes are. It's very useful to do that kind of stuff. So this thing, when I run it, is doing a few different things. It's filling these chunks or the geometry with grains, but it's also adding some attributes. Oh, you do control middle mouse button to get that? Oh, it's very useful. Use that all the time now. So this is doing a few different things with this grain size and mass parameters. It's assigning these as attributes to the geometry that my simulation will know to use. So this is kind of where attributes become so useful, is that the results are more than just the results of like what the geometry is, like actual physical properties or colors can be passed on to later operations. So the mass and the size will be used by my simulation. So if I open this up again, we can see the mass and the p-scale. People use this because you can actually see the values that are on the individual points. Like more advanced things you could do is you could have a variable mass so that it's changing throughout the shape, like certain particles are heavier than others or they move slower than others or something like that. So it's a good way just to see at a glance like which, if this is just all the same value or whatever. P-scale is not position. P-scale is particle scale. P is position. So P is like it's a special thing that always exists, even there's like no way to delete it. If I go up to the top, everything will always have a P. It's just used to lay out the points in 3D space. So, and then there's a special one here that says is grain. So this is like one that's used internally by the solver to mark whether things might be cloth or grain or how to simulate it or whatever. And then V over here is for velocity. So P scale is particle scale, or it's also just used for a uniform scale. So instead of like, if it wasn't uniform, you could stretch things. Like scale usually has 3 components, X, Y, and Z. So you can have like width scaled or whatever. P scale is just a uniform scale. It's like the radius in world space units or whatever. So we have our vellum. Then we'll just make a DOP network. You can do shelf tools. I'm not a big fan of using them, especially for kind of demos and stuff like this, just because the file that it creates is a little bit messy where there's a bunch of different containers. I like, especially when I'm explaining things, I think just visually it makes the most sense to be able to see your process in this like diagram schematic or whatever. So that's why I'm going a little bit deeper than just like hitting a shelf, and I don't know, it's kind of obfuscates too much of the process using shelves sometimes. They're good to use on your own if you're just trying out ideas and just want things like to happen as quickly as possible. So we'll do a vellum object. So this guy's useful because it already comes with these expressions. You middle mouse button on the expressions, you can evaluate them. But this is basically one that just says, get the geometry of the input path of like the parent node, and then 0 is like the first input or whatever. So it's just saying, give me the geometry that's already connected to this. So that's how it already knows to use it. Some older objects and stuff aren't as nice, that they don't have that convenience or whatever happening. So that's why sometimes you have that and sometimes you don't. Like if I do, I don't know, maybe flip object, they could default that to the same thing if they wanted to, but because they don't, you get this like unit box or whatever all the time unless you like clear that out. So this is how we already get that geometry. Sometimes if you do Alt-Shift-T, this will bring up the text port. If you don't want to use the documentation like online, you can copy these, and then if you do xhelp, paste that in, this will give you the description of the, it's kind of like the tooltip if you are typing and hover over it. You can also do xhelp -k, maybe just xhelp, and that will give you like all the possible expressions. Xhelp -k is for searching. So if I do xhelp op, that will give me all of the results with the op. It's like a filter find operation or whatever. So we have the object, and that's it. With Houdini, all the DOP networks rely on solvers. It's just different. Not going to get into the full breakdown of DOPs. It's pretty technical, but you're basically building everything kind of from scratch when you're doing this. So we need the vellum solver. Oops, not that one. Just vellum solver. You can usually tell like these colors here are what gets plugged into what. So that's a little bit of a useful hint, but it's still it takes a lot of time to learn DOPS and really like start building super custom stuff or whatever. So now I should have everything I need. Like if I play, let me just show my time bar. If I play the simulation, it's solving, but in this house, we love DOPS. So the simulation is working, but nothing's happening. So if I just add forces, because this is grains or because it's a point-based solver, I can use these particle forces. So I can plug in the pop force to Gamma Bassoon. Thank you for the tier 1 sub. So if I do just an abstract noise and play it, you can see we're actually starting to move things around. Without any forces, things just come in and sit there. There's no gravity or no default things or whatever. It's like being in outer space, kind of. Yeah, the attributes are super nice. Oh yeah, thank you. Yeah, I appreciate the subs. So like attributes are super useful. If I just had any abstract things, you can use these vec expressions and drive like any parameters. Like basically everything is at your fingertips with attributes. All of these like parameters can be overridden per point. Like you could have different noise amplitudes per particle if you want. So this amplitude here, just different ways to assign noises. This noise is kind of like you're simulating a wind force. Like you have the swirl size of the wind, just an ambient kind of wind force or something like that. So yeah, that's, I would say, the best way to introduce someone to DOPS is that it's like SOPS, but it's time-based. Everything happens every frame. It does get a little bit more, like the way that things are wired together is different, where it's not necessarily passing information in a linear fashion. The way that things are wired together is describing relationships where it doesn't necessarily matter with the order of like things are connected. Yeah, it's not just top down, it's actually top down left to right. So it's like a weird like clockwise thing or whatever. But it takes a while. I'm not gonna go into all that stuff right now. And I'm not gonna do a noise either. So I'll just set the amplitude to 0. We play it again, we're back just in outer space land with nothing going on. It's sort of top down, but it's not, it gets very confusing because like, these are just relationships. So if I did a gravity force right here, you see that this is still getting gravity, but if you think about it like from a SOP standpoint, you're like, but he's put gravity on it before he's running the solver, like how is this happening? But it's basically just because this gravity here is saying to add a force that's a gravity force to my simulation, like as a relationship. So like with SOPs, you're basically running a bunch of different programs where it's saying like, run the Voronoi split program, give me the results and pass it to the next node. Run this transform operation, give me the results and pass it to the next node. And then you can like go down the node tree and look at the results in that kind of sense. With DOPS, it doesn't work like that. Like you're kind of assembling an engine, you're making a plugin that every frame will run a routine based off of how all of these things are connected together. It's not necessarily the same relationship where this is passing information to this that's passing it to this. Like here it's just saying add a gravity tag to this geometry essentially, and then the solver is smart enough to know like, is there gravity? If there is, I'll apply it. And then just using Houdini, like the context is super important. So you always have this little watermark thing or whatever. And that's basically what I'm saying is like when you're in these different contexts or these different zones, the relationships of how things are plugging in is different. The tab menu, all the tools or the nodes that you have are different depending on what context you're in. So dynamics, you're kind of building a little plugin that's going to run a simulation. So get the force back. The solver kind of does all the work, but it's a little bit confusing because the solver doesn't always have the things directly exposed to it, like the code and stuff that they're running. Like maybe the old RBD solver. Like this one, I can't dive inside. I don't really know what's going on. But it's basically just saying like to the software, run this, apply this solving routine that might be like C++ code or something like that that you don't really have access to. And then if it has the right kind of data, it will apply its solution or motion or whatever to the objects. It's a little bit beyond the scope of this stream, but if you read a lot of dops and intro to dops, Jeff Late is a developer. Like he actually, I think he's the one that programmed and implemented it. And he has some master classes where he really goes into the like fine grained details of dops and how it's built and the architecture and everything like that. So pop forces is a little bit misleading. It's not just for particles. You can use it with any point-based dynamics. So even cloth, because it's a point-based dynamic, like you're controlling the points on it, you can use pop forces. With volumes or pyro sims, you can't use these directly on the volumes because that's voxels. So hopefully that makes sense. If you plug it in, there's even a tab here that's named particle forces that makes it a little bit more clear. And then I'll just do negative 9.8 for gravity. Just the default Earth gravity. And then if we play it, we see that these things are falling. And that's when the scale of the scene kind of comes into play or becomes important. If I go back up, let me find my guy. Maybe I need to move him over. Where did he go? He's hiding. Is he hiding? Is he gone? I think he was hiding. So if I play my simulation with him displayed as well, the speed that all of this stuff falls is dependent on the scale. If this stuff was a lot bigger, it would be falling slower or whatever relative to him, if that makes sense. If this was like a little sandbox, everything would be moving at a much different speed. So that's why I was saying that the scale is important, like the size of things in your scene. So we have a simulation, we've added a force, we've added a gravity, we know it's working, but it's not hitting anything. So like I was saying earlier, we added this stuff down here that we were gonna collide with it. We just need to feed this into the solver. But unfortunately, it's not the right type of geometry. Like having grains collide with a bunch of polygonal faces that have like stuff going on inside of it, it's going to be a lot harder for the solver to figure it out. Things might get trapped inside of these little boxes. There's going to be a lot of problems. So we want to represent this geometry a little bit differently. So using height fields is a really good way to like efficiently represent these kind of shapes. So if I just do the height field, whoops, this will create one. Just like an empty one. It's like an empty canvas, a blank slate, empty image or something, but it's way too big for what we need. So we could just go down smaller. So I'll just do 25. Yeah, height fields play nice with Vellum. They work well with, you can even use them, I've used them with smoke simulations in previous ones. And RBD simulations, all of that stuff plays it's super fast with it and everything. So you have a height field. The grid spacing, this is different ways you could specify the resolution. So height fields is like a 2D, it's like an image texture kind of, or a 2D volume. So this is the resolution of my height field or my image. So if you middle mouse, you can see where that's set or whatever. So 512 is a pretty good starting point or whatever. And then just to apply the geometry to it, to have it read it or transfer it over to a height field pretty much, you can just use height field project. Then again, like these wirings, they kind of do a good job of color coding things so you know like what gets plugged into what. Yeah, they did a good job because height fields is a newer, they're doing a better job kind of like 10 years ago or whatever. It was all of the solvers expected different data and didn't play that well together, but they're thinking about everything as they build like future tools and things are integrated a lot better. So it's picking up some of the guys, some of the chunks, but it's not picking up the ones like beneath the height field. It's because my combine method is set to maximum, which basically says use the highest value, whether it's the existing or default value of 0 or the projected like one that we found. So we have other options. We could do minimum, but then we have the other problem where it's just using the lowest value. So we could just choose replace, and then you can see it's picked up either one. So this is saying like disregard the current value and just use the one that this is hitting. And then I think we're pretty much good with this height field. You plug it in. And then to pull it in, there isn't a height field, but it's just named terrain. And then this one you just turn on use height field. And then just merge. So the order of things, like I was saying earlier, how this is a little bit different than SOPs, things as left to right. So like the left affects the right of this merge node with this collide relationship. I also have to, like up here, I said these give you expressions that you can start with. Certain ones don't, so I can just copy this and use it another time. Just switch the input index like over by one value to get it to know. Like basically, these things are just placeholders and you kind of have to reference them yourself. It's not all set. It doesn't know what you're going to be using them for, essentially. So if I play the simulation, we can give it a test. We got a geyser. Got Old Faithful in the middle. But other than that, things are staying above the ground and things are working all right. So with vellum grains, I find that you usually need more sub-steps, just because a lot of like collisions and things like that. Sub-steps are basically just like how many times the solver is going to run its routine over the duration of a frame. So it's going to divide the time into 5 segments, like divide the frame into 5 segments, and then break up the pieces like into smaller things. So it's just moving things in a more incremental manner. It looks like that fixed a little bit of our geysers, flyaways or whatever. We might also want to decrease bounce. I'm not sure if like all of the things use it, but we don't want things bouncing or ricocheting off of this. We just want more sliding kind of action. So turning off the bounce might help a little bit with that. We're also moving a little bit slowly just to like be testing and setting things up. So I'm going to increase the size of the grains So we basically have less of them, like around 50,000 particles. So now you can see we're closer to like working in real time almost, or we just can prototype and fool around and get things done a lot quicker. So we got our little pile, but it falls apart. I also usually hit this little stopwatch when I'm running simulations, just to make sure that I'm seeing things at 24 frames a second or whatever your scene's at. Without that, like you can see it's just playing as fast as it can, so it's a little misleading sometimes where you're like, this is moving too fast, what's happening? So we'll do that. Then we just need to figure out a way to keep them like kind of like this, where there's a container, collisions or whatever. So I think we can do pop limit. There's other ways we could do this. We could make ground planes and like move them around, and then these are kind of like implicit walls or surfaces or stuff like that it will try to. You could see what I'm saying about the order I've plugged things in wrong. So we move that to the other side, and now we have a wall blowing that up, or that explosion is caused because it's like sees them inside of it and immediately just tries to shove them outside of things. So I could kind of manually like position a bunch of these walls, and these extend on forever. But another thing we can do is just use this pop limit because we're dealing with points. So if I plug that, looks like I might need to, might be like a display error right now where it's still, oh, okay, I just unplugged the wrong one. Get these guys wired up the right way. So this pop limit, you can use it to actually like clamp the position to be inside of this box. You can do other effects like wrapping, where it goes from one side and exits that and enters on the other. You do bouncing or other things like that. So this is a useful one. So if I plug it in, now you can see it's limiting or clamping my positions to always be inside of the box, essentially, or whatever my limits are right here. Something happened. Sometimes my drag and drop with Houdini gets a little messed up. I think I fixed it. So now when I'm importing things with my DOP network, with the object, it's set to this asterisk here, which is saying all of these objects that exist in my simulation, the vellum object and the terrain object, import them and bring them back into the geometry or SOP context. What I can do, instead of having this asterisk be anything, I can use it as like a wildcard where it's star anything that so I just want that star to be at the other end of it. So anything that starts with VELL, and then that is saying the vellum object starts with VELL. So I'll retrieve that. This object doesn't match that filter, so it won't bring the ground plane or the collision, the terrain object, back into SOPs. So now I can do different things to visualize it. Like I was saying earlier, I'll usually do copy to points, and then copy spheres. And because I'm using attributes, because I've recorded the grain size, this copy node knows to automatically put whatever shape. You could even do boxes, but it's smart enough to know whatever shape you're copying onto things to use the same scale or radius. And then I can just kind of flip my scene upside down and like frame things up a little bit. Is kind of what we're expecting, what we're getting. So grains, it's a little misleading. Grain size is the name of this parameter. Like, it's like a label. It's not necessarily the actual name. What it's doing is assigning a p-scale attribute. So it's a little misleading in that sense, that this is like a human readable term, is how big do I want my grains to be, and then under the hood Houdini represents that using p-scale. It's a little, yeah, it's just the human readable like label or whatever. It's always, whenever you're using things that for the first time, it's always a good idea just to like middle mouse and see if there's new attributes being added, what they are, and all of that stuff. So you can see we're getting like some weird jittering. So the other thing is that this copy node will try to use other attributes to orient things. It will try to orient these in the direction that they're heading in, basically looking at the velocity. If I don't want things to be considered, usually I use this attribute rename. And then I can look at this list of like all the attributes that might be considered, mass, hit V, all this stuff, and I don't need all of them. So if I get rid of this, it's going to be a bit of a problem. So it forgot about the particle scale, or the p-scale. So I can just add that back in, and then these guys won't be rotating around like that anymore. So that's one thing we can fix. Have some weird stuff happening on the edges. You might not worry about that too much right now. The other thing we might want, some of them still seem to be moving a little too fast, like a jitterbug or something. So if we go onto the solver, we might want to add some velocity dampening. So it's basically like some air drag or atmosphere or something like that, just something that will slow them down over time. So it's, instead of being in outer space, there's like some air resistance or like thickness to the air that will deaccelerate or calm them down. If you really crank this, then it'll be like they're moving through mud or a swamp or something like that. That's like, there's a lot of energy that's spent just to move through an area or whatever. Is there a way to increase the gap between the spheres or particles? There isn't really a way to do it. Everything's based off of that grain size or p-scale, but knowing that, you can kind of like hack your way around it. So if my art director said like I want these to actually be overlapping a little bit, what I would do is make like smaller grains like that, and then the sphere that I'm copying on, make it a little bit bigger. Or after the simulation, I could just multiply the p-scale by a certain amount. Yeah, so just after the post-simulation, change the scale. So you have a ton of flexibility. It could be anything. Like they could say use these pig heads. I'm just gonna pack. This is gonna say like use it as an instance or a reference in this case. And now we have a bunch of little pigs upside down, but Viewport does some optimization to do like level of detail or whatever. You have a ton of flexibility, and then you could change the p-scale or change the actual size of these to be different as well. Looks better with the pig. So go back to the sphere and flip things over again. And the pig, the special pig, there's the disk drive, the like digital only, and then there's the pig edition for the police. So grain size, we can go a little bit smaller now, knowing that like we set stuff up properly and it's working, and now we want to kind of push the detail or the resolution to get better results, even though it will take longer to simulate. So I might want to do This is like 2 million points. It's usually a good idea to actually like see, instead of just visually, like this is more technical or engineering or whatever, but if you actually like quantify your inputs and you know like what you're doing, you just have a better sense of like why things might be running slowly or whatever. I think we're in pretty good shape. So let's just run this and see like what happens, how slow it is or stuff like that. So I just press the up arrow key or whatever. We'll run the simulation. Looks like we're taking 10 seconds, 20 seconds a frame or something like that. So it's getting closer to like how I would work if I was actually doing this for production or whatever. Like you set up your settings, verify that they're working, and then run like a detailed thing that might take an hour to show your supervisor or whatever. I'm that guy Brando. Thank you for the sub. So we'll just let this cache a few frames. This blue line that you see, this is like the simulated frames that are cached. So you can freely scrub or play that area once it's finished simulating. Because I'm displaying like 2 million spheres, it still isn't real time. Like the playback, it's a little bit slow. So what I can do is right click, go back to the first frame, right click on this, and this will just be like, if you use Maya, it's a play blast. Just gonna make a little frame buffer, like playback of my little movie kind of my animation. And maybe I'll just do 24 frames. So like 1 second. I don't need to spend a bunch of time. This is useful when you're starting to like iterate, you're doing heavier data. This kind of bakes everything down to a quick little animation. So I could play this and again, make sure that I'm visualizing things like in real time playback or whatever. So you can see there's some things rolling around, getting some interesting results. To me, it looks like we're on the right track, but it's just now that there's no motion or movement. Like if we go back to this original reference, there's different patterns and things like that being formed. But the most interesting, or one of the more compelling things, is that all of these, the collision geometry is morphing or moving around. So that would be the next thing I would try to add for setting all this stuff up. So like our physical properties, we've kind of verified from a technical standpoint where our tools are working. We've set things up. And then we'll move into more of the animation and like more interesting stuff, I guess, now. Houdini's, I don't know, the effects and stuff like that's pretty interesting because you're like doing all of the different steps, like the engineering, the physical, scientific back-end things, and then you kind of build the tools, and then you can approach them like more of an artist and get the best results out of them. Through displacement and thin layer of grains on top, you could do that. So one of the things I'm going to get into is like getting some more optimizations and stuff like that. So I don't want this to be like 100%, because you do see some particles rolling around and stuff like that. So like you see stuff underneath coming up in certain shots, which makes things pretty interesting. So I want a good amount of thickness, or like not just like a pretty thick shell, I guess, of padding. I have too much now, and we can look into optimizing that to get things speeding up a little bit faster. So I think Corinyan, if that's correct. I think what they're asking is like, you're basically wasting computer space or stuff with simulating things that the camera will never see, which is a good point. We have like 2 million particles, but we're not seeing the detail in all of them. So it's a little bit of like in a thing that isn't optimized right now. So just that we've verified settings and everything like that, I'm just gonna make a new folder for our stream. So I usually share these scene files and stuff like that after the session. So I just like to, then also if we crash or whatever, it's a good idea to start backing things up. This is the 17th. Then I usually work in a scenes folder, like inside of I have my project and then the scenes for Houdini files or whatever. This will be Grain PS5 version 1. So like Corin Yan was saying, there's some optimizations we can do. Basically, I believe what they're saying is like, why waste all the time simulating all of this extra stuff that's like 80% of what you're simulating you're not using, or you're not like visually seeing it. So we could do, I guess, just another blast node and use like this trick we were doing up here to split by position attribute. This time I don't need to do a split because I don't need both results, I just need one result. Redshift versus Octane for Houdini, is it just preference? Seems like a lot of Houdini users lean towards Redshift. Yeah, I don't know, from people coming from Cinema 4D, they tend to like Octane more, I think, just because it's like very well integrated into Cinema 4D. But the Houdini Octane plugin, I think, isn't, from what I've heard, it isn't like as polished in terms of an implementation. So it's kind of just preference, I would say. Just in general, from the standpoint of renders, I would say not to worry too much about like the actual render engine that you're using, and just to focus more on like the something that you can work with quickly. It's cheap, the licensing is cheap, and just do that. Like I would say with Redshift and Octane, there are super fine like technical differences and stuff, but for the most point, all of the renderers right now, they're all using the same kind of equation, and just as an artist, just find one that you can use well or whatever. Yeah, even Mantra like is free and comes with Houdini. It's a bit slow compared to GPU renders, but you could, especially with something like these results, you could get this out of Mantra. It would just be a little bit slower. And Mantra, because it's developed by Houdini, like you have the most access to attributes, custom shaders. You can really create interesting stuff. So it's super useful to know it. So what I was doing here is basically setting an upper limit to my geometry. So we're saying anything that's above 0.7, delete it. So I might do 0.75 just to make it like a more regular number. And then if I go in here, I could make my box a smaller size. So like 0.75, that's half the height because this is like above and below. So if I just multiply that by 2, then it will fit things perfectly. Yeah, it's a little bit of Mantra's a pretty big issue, especially if you're working on shots and like just working without a render farm and everything. It's a bit slow. But it's super fun to use if you're just like messing around making art and you're just making a single frame or whatever. It's cool to play around with. But if you're like trying to run a sequence or a shot overnight, you can't even run. You can't render like 90 frames in a night sometimes, depending on what you're doing. The cycles, maybe once they figure out the USD, the Universal Scene Description, that stuff will get better implemented and everything. Like if I go into my stage context, Redshift is working on support to just have Redshift drop down, and you can like have it in your viewport. If developers like get on their game, you could have just a cycles drop down here, and it would be, because it's all open source and everything like that. I haven't used Solaris too much right now. It's still a bit new. I'm waiting on Redshift to like iron out their plugins. Right now you have to add a bunch of like custom environment variables and stuff to get it to work in there. So I'm holding off on it for right now. So what I'm doing here is just optimizing. So we trimmed off that area. And then if I play things, you can see instead of like 10 seconds or 15 seconds a frame, we're back down to like 1 second. So we're in a lot better shape. We have like 2 options now. We could just work more quickly, or we could increase detail or decrease the resolution of these, like the size of these spheres to have more resolution. But I think for right now, like we're pretty close to what we need for our to kind of match what they're doing. So I'm gonna leave things where we are and just work more quickly. We did that. It was a good call. The Korean just optimize. Why waste time simulating things you're not gonna see, essentially. So now what I'm gonna try to start adding is some. I'm gonna try to do some animations to get just more interesting, like dynamic results. Just clean this stuff up a little bit. Maybe eventually we might do a grain test and see what the performance differences are, but for right now, I'm just gonna try to clean things up a little bit. So this is what I mean, just working without shelves. It's a little bit easier to, as someone more interested in like developing tools, you have a better sense as to what's going on. You have a lot of channel points and some Houdini emotes. I need to add the channel emotes and stuff like that, and the sub icons and everything. You guys have any ideas? The Houdini, I might just steal some icons from Houdini. Kim, you want the Kim Davidson emote? We could probably make that. Let's see. You guys ever hear of the angry fruit salad? I think he exists. So I think if I'm doing like a sub network, you can, maybe it has to be a type, it has to be an OTL or whatever. But like if you click on these little icons, you can usually, maybe this is going to be too big of a sidetrack or whatever. If you go into the HFS, like Houdini file system directory, this is where you can find all their icons and everything like that. I think they're in Houdini, maybe like SVG or something. PDG emote generator. PDG runs everything. Let me just try this. So if I go into the Houdini docs, this is another place that you can kind of see what, if I just find, I didn't do the best job. Let's go back and just go into nodes, OBJ, maybe I'll start with this cop. Compositing nodes, if I look at bright and then just pull in that image, you can see one. So I might use maybe some of these as like emotes. They have, this one here is a pretty cool one. The illegal pixel. Oh no, they don't have it for 18. What happened? It used to be like a little guy shooting a gun at a pixel or whatever. That was pretty cool. It's like getting NANs or like not a number out of your images. Like you have pixels that are brighter than 0 or whatever. This is the rabbit hole emoji. Going down a treacherous path there. But yeah, I'll try to add the other emotes and stuff like that eventually. So, lost my train of thought here. We're adding animation to play around with everything. So, with my terrain, kind of the easiest or quickest way I could animate things is just with a transform. So if I move this, you can kind of see we're sliding our pattern around. So I could just add an expression here. If I just do like $T, that's a shortcut for the time of the scene. You can see things are sliding over. You might want to make my initial box and everything a little bit bigger, just so we have some extra margin, like extra window or whatever. Just go to double the size, double the points. We should have something. So my simulation is happening in a smaller box area. I might have to, it's having some problems right now because it's trying to run like too much, it's trying to create points in too much of an area. So I might not, I'm going to abort that decision. Just go back to what we had with the default scale. The default back to where we were. Another thing I can do, if I do grid, so there's I don't know if this is the quickest way to do it. It's kind of a hack. Yeah, I'm not a big user of PDG or Solaris at the moment. I think it depends on like what your role is as an artist. If you're in the lighting department, you're pretty excited about Solaris and you're using it all the time. If you're like a technical tool developer, you're probably using PDG all the time. PDG is pretty useful for effects in certain standpoints, like if you're doing wedging and things like that. But if you have existing scripts and workflows and stuff, there's not a ton of reason to adopt it for effects, I would say. So I'm just turning these grids into unique polygons, like unconnected, with the facet, and then scaling them down to 0. And then just with this fuse, I'm gonna consolidate or keep them. I think that gives me what I want. Just disable that checkbox. Now we have the 81 points or whatever for one for the center of each polygon from our original geometry. What I'm doing with this, I'm just going to use it with a copy to points node. So I'm basically going to make like a tileable pattern or try to see how well my thing tiles. So if I do 4 rows, 4 columns, then I copy everything to it. We've extended everything over like one repetition or whatever, basically. So maybe I probably want to do my transform after I do that copy, just because it's a little bit better, cleaner or whatever to do things that way. So now when I animate, we do have some seams or whatever, but we'll just ignore them for right now. And then, did I mess this up? I think it's right. So if I play this, we're gonna see a big mistake. Maybe I want to, not that one, maybe, I don't know if that's the best way to visualize stuff. I'll just keep going with this. So if we play it, we can see that things aren't necessarily moving around. We're not picking up the animations happening in our static object. So if I just double click on this and go to my terrain object, I just have to make sure use deforming geometry is on. This will say it's a little bit more expensive. That's why it's off by default. But this will basically say check the input every frame to see if there's changes or to see if there's an update or anything like that. So if I play it, see everything's animating. The other thing is if I was visualizing stuff from within the .NET, I could have more easily seen that this wasn't updating or changing every frame. So going inside of the .NET to visualize and debug things is helpful. So we'll turn deforming geometry back on and just do a flipbook, see what happens. So it looks like we're in good shape. There's a little bit of weird stuff happening here that might be like friction related, or it could be due to the resolution of our height field. There's some gaps that we see in some areas where like we might not have enough thickness in terms of where we're simulating. But we're also simulating like we're doing more area. It's a rowdy little stream. Got a lot of folks in here. So I think someone was very nice and did a cross post or a share on Reddit. We got some new viewers and new activity from that. So we have pretty good stuff happening in the middle here that we're more concerned about. Some of these things, maybe I'll take a quick look. Like it might be, we might need maybe some more sub-steps. Maybe these constraint iterations are they're related to the stacking and nature of grains and how they interact with each other, even though there aren't any constraints in my simulation. So it's helpful sometimes to, maybe I'll go up to 250 with that. And then just my friction scales right here, I might want to change them a little bit lower. So like, if you're doing like a powder, you might expect the friction to be higher so that they sit on each other a little bit better. If you're doing sand, that might like sift through itself a little bit easier. And then, I don't know, like caviar or something would slide. It's a lot more slippery, so it would slide past each other more easily. Let's maybe increase our flipbook time up to just like 128 and do another simulation, see if we've improved any of those aspects. So it's, if you're getting started, it's like a good idea maybe to keep a notepad or a text document or something, and you need to keep track of every little change that you make and not necessarily make more than one change at once. Once you know what you're doing, you could start changing more things, but it's super easy as you're getting started to like try 8 different, be like one of these 8 different things has to fix it, and then something else goes wrong. It can just turn into a mess or whatever. So it looks like these things are a little bit better. Something else I'm gonna do is just go up here. So we do see some like aliasing or stair-stepping. So this is kind of because we're going from like vector-based to a raster-based format, where this polygons here, they can do sharp edges and stuff like that very easily. But the height field, it's more optimized for simulations, but it's a voxel or pixel-based thing, so super sharp angles like that it has trouble with. You can do a higher resolution. It's going to be a little bit slower to rasterize or to convert from polygons to pixels every frame. Another thing that we can do is if we just do the blur, height field blur, with this one, just a small radius, you can fix those areas a little bit, just like smooth or subdivide or whatever. So we might want to do that, and let me just go back to my first frame. maybe I'll do another flipbook. So this viewport cache or whatever, it's just a little bit slow. So it looks like that cleaned up some of the issues or artifacts or stuff like that that we were getting before, like the real jittery, I don't know what you want to call it, but it just is very eye-catching and looks like a mistake, or it doesn't look good. Looks like we have some stuff happening here that might be a little bit of an issue, but for right now I'm just going to ignore that stuff. This might be related to like the edge of my container. Basically this limit, because this is like clamping things to the frame, to the box or whatever, that can cause some issues like that. Could also be due to the tiling nature. Just make sure my spacing is correct. So I think I had some overlaps happening with my grid. Yeah, so instead of 25, I should have been using 30. So that was a little bit of a blunder. I'm sorry, guys. We'll power through it. So, to do another flipbook, and pretty much all of those issues should be solved. So basically, our repetitions, they had some overlap to them, and that I think was causing some jittering or artifacts where the conversion didn't know which surface to find, and it was changing, every frame was finding a slightly different surface, and we were getting like this jittery or whatever. So some of this stuff, it might be a little bit too smooth. We might want to reduce that blurring just a little bit to preserve like some of the sharpness. So we reduce the blur radius, basically get like less blurring happening. Maybe go up to 1024 for my resolution. And let's do another flipbook, see what happens. So this, we're getting some really cool stuff there where it's like pushing, shedding stuff aside. Super interesting. It's a little bit boring because it's like just a linear motion from side to side. Yeah, the VOD will stay up for, I think, like 45 days or whatever, and then Twitch just kind of deletes it or does something with it. They yeet it somewhere. I also upload it to YouTube. If you go to my website, there's a link for the YouTube or whatever, or in the Discord. You go to the panels below my stream, there's a link to join the Discord. I think I just moved it to the social link area, but that area has like the archive of older streams as well. So then the scene files as well will be available to, it's a little bit easier to work or to debug things that way instead of like trying, sometimes I go through the parameters too quickly and then you don't have to like manually write everything down. But recreating things that way is very useful for learning. Like I wouldn't say to completely disregard it. Like rebuilding everything a second time is super useful way to learn. So I'm gonna modify this expression so we're not just doing the linear offset. I'm gonna just try under rotate. I'm gonna do $FF. So this will do it by frame. So because translation, we're doing smaller numbers, I'm using like the seconds in time. And then rotation happens in degrees, like 0 to 360. So I want bigger numbers, so I'm gonna use the current frame. So if we just play from here, you can see we're getting some translation and then also some rotation. So this should make my results a little more interesting. So instead of just one direction or whatever, this stuff here should be a little bit, you get better, I don't know, dynamics or friction or whatever when there's more interesting motion or whatever. So let this simulate out. I'm gonna get some water. I'll be right back. This is a little bit more cool, I think. I don't know. So we have a few different options here. Probably gonna keep going with the stream for another 30 minutes or an hour. We'll look a little bit at like shading and stuff like that with Redshift. And if we get to it, we'll either try like grains. This vellum stuff seems to be working all right, so it's not going to be a super big priority. We could try some other patterns if we get to it. So for shading, if we go back here, the one thing we want to add or think about with our simulation is like these little patterns that seem to emerge. You think it's better to have them rolling like the other way? We could I'm not going to spend too much time setting that up. I'm just going to keep going with how they are right now. So I think one of the things we could do is like flip it over and try stuff with like gravity going the other way, and then we would have some stuff rolling over. But it seems like, I don't know, it depends on from shots to shots. Sometimes there's stuff that's flying up, but other times it looks to me like this is the way that I've set it up with gravity going that way. It's hard to know, but it would be interesting to try other things. If right now I'm just going to keep going with like the shading ideas. So you would see it's highlighting little areas, and certain times it's like certain times it's a little bit I don't know what the best word is, like there's not really a decision based on, it's just like a noise pattern or something, it's like a texture. And then certain times it's like the edges or the corners highlighting stuff. And they always seem to be buried a little bit beneath the surface. So certain ones are like, even at the front, stay black, and that adds some contrast and makes things look pretty interesting. Like this area here never completely blurs or glows to blue. So we'll try to simulate a few of those things and see how far we get. So I think we have the height field. I think we have some different operations and stuff that we can do with it. under the terrain section, you can just go to that sub menu, and then you can just view all the different operations that you can do with the height field. I'm looking for something that can kind of like extract the different features of things. What I'm actually going to just do is convert the height field. So this is switching it from the image kind of based format, or like voxels, to actual polygons. So you see that we actually have like a wireframe or grids and quads and stuff representing things. And then the reason I'm doing that is that so I can use this measure node. So this one, you can measure like the area, all the different aspects of topology. Area, like edge length or perimeter. This curvature is super useful for, I think if I go into this tooltip, the transform one or whatever, then I can see the visualization. So this way I can see the crevices, like the cracks or whatever. So it's super useful for if we want to highlight or accentuate certain visualizations of it. If I do bake visualize range into output, that will actually assign, it should. Maybe it's just, okay, so that's just changing the range. It's not actually baking the visualization. So what I mean by that, Rich, good to see you. Yeah, thanks it's good to talk to you on Twitter, and it's good for you to finally come by. So we're just setting up, trying to recreate like the PlayStation 5 kind of simulation technique, and then a little bit of the look to it. I'm taking the height field right now. With this measure node, I'm just storing the curvature of the geometry in an attribute. It's this curvature right now. So what I can do with a color node is I could add my own ramp using that attribute. So if I just go to class for primitive, so you just have to be a little bit careful here with attributes and what class or what part of the geometry they're stored on. So I'm looking at the curvature, and then I can do ramp from attribute, and then with my drop down, looks like this defaults to just point-based attributes, but I can type in what I want manually. So now we have the curvature. I could play around with my ramp here to get different contrasts. Sometimes I turn off the lighting in the viewport just to be able to see, and then the wireframe and everything, just to be able to see like the raw output or whatever of what happens. So maybe we could already start a little bit with like a visualization just to get something close to the blue that they have in that the PlayStation 5 blue. So Maxime was already using that blue color in all of his works, and then it was almost like Sony took that that blue glow color from him, blue balls. So maybe we want to go, maybe a little bit more of the saturation or whatever. Pretty good. We can do attribute transfer if we want. I'm just going to wire it up like that. So the attribute transfer by proximity will copy over certain attributes from one input to the other, but they have to be the same type. So this is, again, just with attributes, we have to be a little bit careful. We have a color, the CD is like color diffuse, but it's being stored on the primitives over here. So the actual polygons or the faces hold that value. And then if we want to copy it over to these points, we just need to move it from one to the other. So if I do attribute promote, this way what I can do is change the class. We're going from primitive. We want to use the CD. You see it gets a little bit blurry just because that's how it represents stuff. When you go from faces is like a hard edge to the points, it interpolates the value across the face. Then you can see we have our kind of glowing look. And when I copy it over to the spheres as well, you can see it. We might want to go with our ramp like a little bit higher than 0. 0 will absorb like all of the light. Sometimes you want a little bit of, I don't know, I guess we could just rely on the specular to give us the highlights. It looks like that's more of what they're doing in the video, in the reference. These are actually like a black color property, and then the highlights or the reflection is what makes them still visible. So if we want to maybe hide some of these a little bit, we can do a noise. So if I just do, I might be able to set it up this way. So if I just do attribute noise like this, this will let me generate a noise texture and assign it to the color information. So I can do 1D maybe to, this will just change it from a 3D color noise to 1D will just be like a single value or black and white, like a grayscale. And then mode instead of additive. Should be adding it to the existing multiplicative. Will multiply just like the operation or whatever that's being used. This is more of like you're applying a mask or whatever with the multiplicative operation. You might want to do remap the noise. So this way I'm changing like the contrast or the range that the noise is in. There's like ramps and a bunch of other stuff. But I think this remap operation is what I want to do. And then element size is kind of changing the scale of stuff. If I disable this original attribute transfer that's assigning or transferring over the color, then I can just visualize the raw output of this node and get like a little bit better of a sense of set up my texture this way. So we're doing maybe something a little bit more like low frequency, blobby or diffuse or whatever like this. And this roughness over here is kind of like a gamma or sharpness or whatever. We might want a little bit of like patchy areas. I haven't really used these distribution ramps before, but I might try it out now. I'm trying to kind of just get like a harsher kind of contrast. I don't know if these are necessarily what I want. I might want to just work with the amplitude and then with this post process. I don't know. I'm trying to stay out of ops because I don't want to make this too complicated right now. So I'm using like a higher level, or just an easier accessibly to set up or to use for the first time kind of node. So I'll just switch to remap, and I think we're pretty good with how it is this way. So we can also do animated, and it looks like that's kind of what they're doing in the in the video, in the reference. So if I switch this input to go over here, I can play back stuff kind of in real time. I think the first and last point should be 1, and the middle should be near 0. It's a little bit of an odd way. I guess that kind of makes sense. Give it a try. So this this is more of like a, I don't know how to describe it, but I think I understand what you're saying. Thanks for the swooping in like a medic. So now I can get a little bit better contrast. So I'm just trying to get a specific area to be very bright and the rest of it to be like close to 0. I don't know, this is a little funky. I might I'll just leave it. This is a little bit of an improvement. So I'll just leave this. I'll leave that where it is. So like I was saying, we can add animation. I got a little scared by this. I got intimidated. So I could add animation here, and then using this pulse duration, this is how you control the speed, like how fast or slow things are evolving. So this looks a little bit better. Like I don't really want everything sizzling or whatever. I want more just like an ambient pulsing, like something's breathing more of like, instead of a frantic sizzling or whatever. And then I think maybe on this color, should be pretty good. Sometimes depends where you are in your pipeline or whatever. Like sometimes I'll make these values bigger, brighter than 1, kind of like high dynamic range. You can do that in the shader, or you could do it right here directly. But it looks like that's kind of a little bit closer to what's happening. Oops. In the reference, some of these are like blowing out or clipping to white. They're not just they're like overexposed essentially. So we can go higher than 1 with some of these to get like the bright regions. And then because our noise is multiplicative, we can still ramp some of them down to 0. I can change. Yeah, I don't know. I wish that there was just like a contrast or more image correction kind of based. I'm basically trying to just get like certain slivers that are bright and others that aren't. Maybe just my element size. Starting to get a little bit of a little closer to where I want to be, I think. So we're in pretty good shape, I think. Just do another flipbook with the results. So we have our simulation, we have the textures or the noises that we're animating on top of things. We'll just give that a quick play blast to kind of see what's happening. Flipbook. So the people that were asking about attributes earlier, hopefully you can kind of start to see the power of working with them in Houdini, where we use them to change like the physical properties or the size using the p-scale attribute. We can compute new ones, like using the measure shop to find the curvature, like the cavities or the sharp areas of the mesh. So yeah, it's the secret sauce of Houdini. It's definitely the reason why so many people use Houdini. Even some people don't even use the DOP networks at all. They just use SOPs just because like doing procedural modeling, it just makes a lot more sense to store attributes and do all that stuff. So there's like some sizzling stuff happening, but I think we're okay. I might just change this noise function up a little bit to try to solve it. Because I have cached the simulation a little bit. I think it's still a little bit slow just because of all the other operations I'm doing on this side. Over here, like if you middle mouse button on some of these nodes, you can see how long it's taking each one to process. So like my measure operation that I'm doing for curvature, I can see every frame or every time to cook, it's taking like 2.25 seconds or something like that. So that's why things are still a little bit slow. I'm gonna reduce the roughness to try to fix some of that sizzling. Maybe we'll do like less octaves. Maybe it's just a little bit too high frequency. So we'll try something closer to that. And then let's, whoa. Something happened. So should be good now. Let's give this another flip book. So we might have fixed it a little bit. I think it's just a little bit flickery because so many different things are changing in terms of the mesh. Like the curvature, every frame is changing a little bit. So what I can do with my color, I think if I switch this range up a little bit so that we're grabbing more of it and making it brighter to begin with, and then apply the noise, it should be a little bit less flickery. Maybe I've kind of messed myself up with the settings a little bit here. All right, so maybe something like this. You also have the option if you want, because we're doing multiplicative, like we could just layer these. So what I did is just put 2 on top, so it's kind of working like a gamma, like a power function or something like that. We could also offset them so that we have like two noise functions. Do a little bit more interesting of a result that way, I guess. Maybe I want them going at different times as well. So we have like one that's a little bit bigger of a pattern moving slowly, and then a quicker one moving more quickly. Or a higher frequency one moving more quickly. Sorry, that was misleading. So I could play them. I don't know. This is still feeling. My pulse duration seems a bit of a mess. I'm just gonna do another flipbook and see what it looks like. This color's sitting nice. It's like it's a it's a very useful skill to have, is like dialing in the colors and shading and stuff like that. Chef's kiss. So yeah, you can, a good lighting artist or someone with a good eye for shaders or whatever, it can turn like a disaster of a project into a darling just at the very end. If not all the time, but it helps a lot to know just how to light things and make it look good. So I think that what I was doing with the exposure, like when I boosted the end of that ramp to get things blowing out to white, really helped me out a lot. So if I was doing this project properly, I would want to change the order that these noises and stuff are happening. I think I can do it all the way that it's set up. So because all this stuff is like you saw the PS5 reveal too, and it looks amazing. Maxime is known for this art style, and it looks like he made it for Sony. I don't know who made it. I've seen people talking about it like on Instagram or other stuff like that. I haven't heard if they at least, like, you need to at least hire someone on as a consultant, even if they aren't actually making it, like as a art director or some type of consulting role, without completely just ripping someone off. So they like I was saying earlier, he should get some lawyers or something like that if he wasn't compensated properly, because it's a one-to-one rip of like his earlier works, even in terms of, it's not like they just use, sometimes you get away with it and you're like, oh, they both used grains, they both whatever, like you don't know if they actually ripped like 100%, but this one compositionally, like motion wise, like everything is a one-to-one rip-off. So they should have definitely given him credit or paid him or brought him on for, like I was saying, a supervising role or some aspect of it. I'm gonna try one thing quickly. I don't know how well it's gonna work, but basically because our position, we're using the position attribute here to compute the noise. It's always updating, so we can keep blasting away with our attributes. So if I do a rest position up here, this is going to make a copy of the position before the simulation and store it into this rest attribute. And then after the simulation, I can keep the rest as well as the p-scale, and we can use that to calculate the noise. So this is like using rest space in a shader or something like that. And basically, instead of using the live position as it moves around, we're using just the static copy of our position attribute. You want me to buy some followers from you? I'm not interested in that. So with this noise texture stuck, we might be able to clean up a little bit of the swimming effect of things. I'm not 100% sure if it will work though, just because we're already like transforming and sliding the collision against the grains. So we already have a little bit of like a swimming texture look to things. But I think, looks like things are a little bit better. I don't know. All right, I'm gonna do one more thing to fix it. Gives you the moonlight. You think it's good having you're talking about just the swimming texture gives you a moonlight reflecting feels? Or just overall? So I'm going to try one more thing. Instead of using the rest for this, I'm going to go back to P. What I can do with this transform up here, I can do a reference copy of it and do that same rotation and translate, like replicate that entire thing. So that my noise, the position here for the noise will get rotated as well. But then I don't want my end result to be transformed in this manner. Like, I think what I can do up here is kind of show you what's happening. So what I'm doing here is spinning everything so that the noise is calculated in this transformed position. But then after my noises, I can do another transform, and then this time invert or undo, kind of revert out of that position. So now my noise position or texture is flowing in the same manner that those collisions are moving. So let's see if this fixed it. I don't know, it's like a pet peeve of mine to see swimming textures. So it's like, why did you do that? I might have gone the wrong way with it. It looks better. Like this kind of stuff is shearing through it. Could just be something that's gonna, I just haven't dialed it in properly and it hasn't looked, Alright, let me try one more thing. So this one I'm gonna invert, and then this one I'm gonna go back to the other one. So this is basically gonna do the opposite. Like, instead of rotating this way, it will rotate that way. While this is going, let's just take a quick look at this, kind of start to think about how we're gonna set up lights and stuff like that. So looks like just the area light is the only light source on the top. Specular, this kind of looks like a rubber material. So it should be a pretty straightforward environment to kind of set up. Yeah, the swimming texture is hard to get away with sometimes. Like, you definitely have to nail it completely to not make it look like a amateur hour. It's interesting because some of these, like on the close-ups, they look a little bit more like glass or something. But then as you get wider out, I don't know. Like this area light in the reflection looks pretty smooth. And then further out, looks like a little bit of a sharper. Like this looks like a little bit more of a blurry reflection. I don't know if they used a different shader. You guys see what I mean? Looks like they, yeah, I don't know what they did. They did like 3 different shaders for each of the shots. I'm guessing like a supervisor or someone had a comment. For the first frame, they wanted a very specific rim light and silhouette and stuff like that. Or it just didn't look that good when you saw all these crisp reflections of the spheres. They didn't want like all that. They wanted a cleaner frame, maybe with less stuff happening. But that's probably what happened. So I'm just gonna try to match the look of these later ones where I'm not gonna do any macro shots like that. Let's see if I think we did it. Took me 3 different tries, but the swimming problem looks to be a little bit better now. I think I don't know if we'll get to it, but having more animation in the collision stuff should be a better way to work around that problem. Like what I mean is that each of these spikes or chunks or whatever should kind of be deforming independently. Like the way that I've just uniformly translated everything was a bit of a lazy. So I'm getting into a lot of problems later on because I kind of made that lazy decision. We might get to it where we properly animate like deforming textures instead of this rigid, just spin everything, because I think that was a big issue. I shouldn't have done it that way. We can just get started though with this scene. So we want to start rendering. I might do another transform here just to get stuff. Just do -90 to get things at least facing the right, along the right axis or orientation or whatever. So I'm not lighting and setting up cameras in like a horizontal. It just gets jaunty if you're working like Houdini likes Y to be the up vector or the up axis or whatever. So I want to transform myself out of it pretty quickly. If I want to, I could do like a mirror, I think. And just as a quick hack, get two things happening. So if you were working as someone as like a style frame or whatever, this this way would be acceptable to make like a still, but then if you were to play the animation, it would start to look pretty weird. I don't know if it seems like the normals are getting reversed on that other one, so I might just do another transform. And then this one I'm just going to do 180 and move it. And then just merge them together. So I'm basically just doing this to set up the form and composition and stuff, but for motion and things like that, I would probably want to redo my colliders and everything like that. So we have our guys. Just gonna do a RS light. It's like an area light. Move it. Let's do -90. You can also rotate it with these gizmos. I don't know, I'm kind of OCD, so with rotations, I just want them to be 100% locked. So we'll just quickly kind of model that in. I'm just going to ignore the walls for right now. Like they should be in there because with reflections and stuff, it would make a pretty big difference. But for right now, I'm just going to ignore them. I'm going to make a material network and just make a camera. So because I'm completely like biting off their look, I'm going to set up camera pretty similar to this. One of these situations. This is like the two sides one. Maybe I'll start with one of these, so I actually don't need my duplicate. My light, I want it to be longer in this direction instead. Maybe do this kind of camera from right there. Again, I usually just make these, rotate them, the Z, make that 0 so we're symmetrical. And then with this light, let's make this a little bit wider. So it should fill pretty much the entire width of the space. Something like that. And we quickly just make the rest of the environment. So if I do a box here I can scale it up, move it over a little bit, and then just go in, delete some of these extra faces. Then I probably just want to reverse it. You would see by the tinted faces or whatever, it's facing the wrong way. Now I've reversed, but the normals are like conflicting with the reverse I did. So I can just do a normal SOP to have it recalculate with reversed. It's a little bit under the hood or whatever, but this one just changes the winding order of the like connectivity, and then this one changes the attribute. Depending, like Redshift might just look at the winding order and it might not look at the attribute, so that's why you have to be a little bit careful. So maybe we'll just pull back a little bit with this one to get more of the walls, match the frame a little bit better. With this light, I just want it to be a little bit longer. I think that's the wrong one. So it goes something kind of like, whoa, kind of like that. And we should be close. Just make our material, RS material builder. This one comes with something kind of close to plastic. We'll get started with that, and should be ready. Just gonna make a new pane. Redshift render view. Set the camera. Then if you just hit the automatic render button, we have a mess. So what's happening? So a bunch of different things are happening, I believe. I think our light, it uses this intensity here to make it, the bigger you make the light, the less intensity you need, if that makes sense. So you can make it smaller. Now we have more of a space or a realistic room that's the light intensity kind of matches, but we can't see any of the grains. So the problem is that Redshift doesn't know what to do with these sphere primitives that I've copied onto points. You middle mouse on this, you see that it's just one sphere, whereas earlier we had a bunch of points. So Redshift doesn't understand what a sphere mesh or geometry type is. So what we can do, I'm just going to do this transform earlier. If we wanted to, we could use this node here as a visualization. If I press the T, put it there, then this moves the render flag over. So Redshift or whatever renderer I'm using will see this output or this geometry, and then the viewport will see this visualization. And then with my Redshift settings, I can just tell this to treat it as particles. The Redshift implementation is smart enough to know about the p-scale attribute. So when I set things up, it knows what to do with that. Microsoft, make it green. It's like a Monster, you could do Monster Energy with the same green as well. The original Xbox was a big Monster Energy console. Like just the design is like the same industrial designer could have done the Monster Energy packaging. So I'm just going to clean up the names a little bit. Particles. When I change the name of this, it's recalculating all of the simulation and everything inside of it. So that's why it's just has to update everything. And then this one will just be walls. Gamer fuel. It's like the Baja, we could do a Baja Blast edition. Yeah, so I don't think it's necessarily the specular roughness. There's a bunch of things going on right now. So basically our default plastic material doesn't have any specular roughness. I can turn this back on. You want the Code Red edition? But you play around with different colors. I think the biggest problem is that there's a diffuse. Let me back up. Spoke too soon. So my biggest problem is that I haven't linked up the shader yet. It's using a default material. So I'll assign my material properly. I usually do this relative path. And then let's see what we have. So yeah, I think that there's a few problems. I think that we don't want any diffuse, essentially, because it looks like in their reference I see two main things happening. I see like incandescence or emission, like self-illumination, and reflection, and then there's no diffuse, or things go to black when they don't reflect any light. I'm just gonna turn this region thing on. I feel like redshift kind of makes me drop some frames or whatever, but we're still in somewhat good shape. We went back to like PS2 frame rate right now or something. So I'm just going to introduce some roughness. So what that's doing is basically changing the amount of those highlights that you see. So the more we add roughness, the closer we get to rubber. I think, I don't know, maybe something like this is close to where we were at. It's like the Nintendo 64 when you, on GoldenEye, when you fired like the grenade launcher, it couldn't draw that many explosions, and it's like 1 frame per second with like the multiplayer or whatever. Redshift's my render of choice for most things. I still use Mantra for a little bit, but just working without a render farm, like locally, I think a GPU renderer makes the most sense. And then when I was switching over, Arnold, the GPU render wasn't that far along, the V-Ray one wasn't that far along. The Redshift implementation just seemed the best for Houdini at that time, so I just stuck with it. It seems like a lot of most of the Houdini tutorials and stuff use Redshift as well, so I don't know. If you're beginning, it's a good one to start out with, I would say. So we're good. We're done. We're final. No, we still need to get this color information into here. So we can do that with Redshift is super good because we can just read these attributes and use them in the shader. Not all third-party renderers have that flexibility, but Redshift is integrated pretty well. So I can do CD. You just plug it in directly to Surface. Then you just can visualize like the raw value or make sure that it's working properly. But we want to actually modify or drive the shader using this attribute or using this information. Julian, it's good to see you. Yeah, the VOD will be available. There's no worries if you're late. So with this color, Redshift being able to read p-scale and point attributes and all that stuff is definitely one of the major reasons it caught. Yeah, I think they were the first ones to really nail down all of that stuff. Like even right now they support packed primitives and a bunch of things that other renderers haven't caught up with supporting, even like style sheets and super advanced stuff. So it's a good one to use. I haven't used Arnold's integration recently. Like I used it 4 years ago or something. It was super good at that time, but it seems like maybe that since Autodesk bought them, they're like, we're not going to spend time with Houdini, or I don't know, something happened. So I can expand all of these different slots and see the different things that I can drive. We see this emission color at the bottom. So this is a good one, I think, to try it out with. Let's see what happens. Nothing happens. So I think on our material, under overall, I have an additional emission weight thing that this is just another multiplier. So I can make it more intense. I can do, like I was saying when I was setting up the color, like you could change your stuff later on. I might want to do a color correct right here to Yeah, I mean, I don't know. If you're investing in learning and stuff, it kind of makes sense to stick with one and just spend time learning it inside and out. Like, you can kind of get yourself into a mess learning too many things at once. But it might make sense to reevaluate or switch. I don't know. Octane seems to be getting a lot better now, though. So what I can do is just do some slight color correction to the texture. I can also do color correction to the final image, like using this RS Post Effects panel. So you can do different stuff here, like tone mapping to keep these highlights in range. I think it looks more like the reference without that tone mapping. I think my gamma was a little bit better before. Might want some more like intensity. The saturation scale might be, give it some deeper saturations. I don't know, that doesn't seem to work too well. I might want to go back to the ramp and reassign some of these colors if I really want to finesse the tweaks. It's not the best idea to like do a bunch of different color operations across your chain. You want to set everything in one place, kind of. You can also do this hue shift that's pretty powerful. So you can get into like toxic infection land. If you get into an orange area, you can get some interesting, like, kind of, it's more like a fire or like a black body. Bloom. So we can find maybe like this is like the Baja Blast somewhere in here. Somewhere over here we have the code red situation. So you can just do this and approach all the big brands with your rip-off of a concept. So this one, yeah, is closer to the Xbox. There we are. Hey Microsoft, I have your trailer ready. So let's just turn this off for now. We could try the bloom. You get some nice glow effects. You can also use this to additionally like blow out the highlights a little bit more if you want. So you have threshold, and then softness is like the radius of the bloom. If you really want to get carried away with it, you can do the streak. So this one would add like the glints, super expensive, luxurious stuff or whatever, like a diamond. We could try this photographic exposure. So there are settings here where I can get it back closer to what they had. So if I do allow overexposure, that kind of reduces like the tone mapping effect a little bit. You can play around with this allow desaturation as well. So that will kind of like desaturate colors as they go beyond one, or they get brighter than white, essentially. And if we look here, it looks like our roughness is a little, like it's too sharp. We don't have enough roughness. We might want a little bit more. With the IOR, like index of refraction, basically you go from completely, you're at 1, you go from completely diffuse or no reflections, and then the higher you go, the closer you get to like a metal or something like that. I'm still working with ASUS to I haven't taken the time yet to update to that, but that should be a lot better for the proper color. So we might be a little bit too shiny. So maybe something like that's pretty good. Now seems like we're bloomed out a little bit too much, too powerful. So maybe increasing the bloom threshold. So we're just kind of blasting out those things. Then we might want to make another material for the walls, the environment. Those things, it seemed like it was just because you don't see the reflections or whatever. These just look like white paint or something like that. So I can just go into paper. I don't want any backlighting. That's for like light blowing out the other side. Like if you have something like paper, like that's thin, but these walls would actually be thick, so we don't want like the backlight bleeding through or whatever. And then maybe this will do particles, just to keep organized. Walls. So now we do another render and we're a little bit closer to our reference. Looks like those are getting a little bit brighter. Might just be that the light, I'm seeing more highlights on the actual particles. So it might be, let me see what happens here if we just go. It might be a little bit more intense of a light. Could be just a little bit higher of a roughness here. So I'm increasing the IOR there to get a bigger like reflection response. This is, I don't know, it's feeling a little bit better. I'm not going to go super super over the top dialing it in. Like if you really wanted to spend time, you could looks like they don't have any bounce lighting, but this maybe having the ground black, that's what's allowing them to get more deeper, more contrast or whatever. So we could set, that's one thing that would make a pretty big difference. I'm just gonna grab this under color. I can set this pretty dark, and then they're using the shapes. yeah. So I'm gonna I'm gonna stop this at pretty soon, but I'm gonna try to get some of these other shapes and ideas and stuff like that in really quickly at the end. But yeah, I mean that's the only thing that they really did to differentiate themselves from Maxim's original artworks. It was like everything is the same as one of his pieces, except even this stuff he was doing it before marathon streams. So yeah, they have the boxes going in and out or whatever. It's pretty cool. Yeah, that was a good way to lay that out. So I'm just making the ground black. Right now I've assigned it to the point that you see we have that interpolation happening over the faces. So what I want to do is switch to primitive. So we're able to do per wall instead of like per corner of the wall, assigning the color. So with this attribute, we want it to be a primitive. I'm not sure exactly what you mean by depth-based color particles. I guess there's different depths you could measure, like distance from camera, distance to the wall, and things like that. So we just need to add that color into the shader. I think we can do it using the same workflow we did before. Just gonna override the material. Looks like it doesn't work. So this is happening because we've assigned it to the primitives instead of the points. I think we can do maybe vertex. There we go. So vertices in Houdini are a little bit different than points. Like I can only have one point at the corner here, but I can have 3 vertices or more vertices or whatever. Z depth. Yeah, that could be cool to add some scale. So we can do that with stuff in the shader, I think we can also do it with the light. If we add volume contribution, and then under the Redshift render driver, they have the volume. You can turn that on, you get like a mist or something. You could do it in object space as well if you did to bake it in the attribute. So there's different things I can do here, is like scattering that will make stuff brighter, and then attenuation will just make it like this fog is absorbing the light. I can do different different things here. That's kind of like a Z depth. If I go into the, I'm just going to turn that back off for right now. If I go back into the, turn off volume contribution. So if you wanted to transfer over depth, the easiest way to do that is with this ray SOP. It's kind of like the height field project, but for polygons and surfaces. And then kind of working in different spaces right now, so it's a little bit confusing. But what this is going to try to do is like move the points from where they are onto the surface. You can do either project or minimum distance will like snap to the nearest position on that template geometry. We can turn off show guide geometry, and then that gets a little bit more clear as to what's happening. So this just finds by proximity the nearest position. But instead of actually moving the points, you can store point intersection distance. So now if I middle mouse button here, I see I have a distance attribute. And then with my color node, if I go to ramp from attribute and pick distance, you could use this as like a depth from the collision geometry. It's just an additional way to modulate or modify things. I'm just going to keep it the way that it is right now, though. So it'll be find depth from collision. This could be cool to work it in, but it's a little bit more involved in terms of the maths and stuff like that to combine it, like composite it onto the existing colors and everything. So I was just updating my walls. So we verified that this worked after switching to vertices. Redshift is smart enough to know about points and vertices. So I can just go back to changing this to the diffuse color. And now we have a little bit more realism because we have like the bounce lighting and stuff like that happening, which is pretty cool. I think it's not necessarily bounce lighting, it's like reflections. If you want additional bounce lighting with Redshift, you can get all that stuff under global illumination. Just do brute force GI. Then we should get like, it might not be that different because we don't have a lot of diffuse materials, but like you'll see the blue stuff bleeding a little bit more around the edges and stuff like that. It's like super luxurious GI, super expensive brute force. So the GPU does it super quick. So this is pretty close to the end. I'm just gonna save this with that underglow. It's a little glint. So compositionally, you might want to move noises around or whatever to like have that catch your eye, depending on the art director or whatever. But I'm gonna look at different ways now to change these shapes. So like we started doing this Voronoi method. I think what I can do, just gonna take this height field, take the grid, and go from here. So Mr. RH2 smart enough to realize they were doing this motif of the buttons. Still part of the honkers. You guys have some inside jokes. So we could do X with the font node. This way we just get the X ASCII character or whatever. But there's like some smoothing. You might want to change the font, like Helvetica. If you want the actual ASCII, if you do like Courier, I don't think we want the serifs and stuff like that. Maybe new? I don't think so. Also, Arial Bold is like a pretty, just maybe Arial is like a pretty standard looking font. Font printer go brrr. So, well, yeah, the drop down for the fonts is pretty intense. Then what I can do is a scatter to locate or distribute points. I'm gonna turn off that other stuff again. We'll just do like 13. And then I can do this copy to points again. They're laid out a little bit wrong, so I can just do transform, do 90 degrees to align them to the y-axis instead of looking down the z-axis. So I have a few different options here. I could just scale these up bigger, or I could change like the p-scale of the scatter if I wanted to. I can also do this poly expand. So this is a good way to change like the thickness of fonts and stuff like that. Like it's more similar to Illustrator operations or stuff. In the past, like this is it's harder to do this operation in other 3D software or whatever. This is a new node that Side Effects made that's pretty good. I can get rid of some of this, like some of these extra points. If you do facet, you can do remove inline points, and then based on how much curvature they are, how straight, like this will only keep sharp edges. So we'll delete by curvature or angle, kind of. So then it will get rid of that problem I was having a little bit with the stuff like sloping in too much. Then maybe I want to do a poly extrude. So this way I can make them 3D with thickness or whatever. Might want to go up. I can also use this inset to kind of give them that beveled sloping kind of effect. So we have our fonts. Maybe we want them a little bit bigger. Can do more of them or different distributions. To move them around, we can do a few different things. Maybe this attribute noise is good again. So this one we were using to assign the color noise mask to the particles. We can also use them to move the position. So my source or input coordinate is position, but I also want to add to position. So if I do that, you can see they moved a little bit. I want this noise centered, like going in any direction instead of only positive positions. And then if I increase amplitude, you can just see a little bit more displacements, and I can use animated. So over time, they fly around or swim around or whatever. Maybe we want the scatter noise. You think I don't have enough X's? X's and O's? More noise? Oh, the amplitude you think should be more? So we're a little bit better. Maybe my amplitude for Y, not as much. So this is, we're just doing like a 2-dimensional kind of noise. Got the fireflies out. So these will all apply to the X's and everything like that. So it looks like maybe my element size should be a little bit bigger, like the swirls and stuff. You don't really see them like change direction in the spot. It's just like they're all moving linearly in one direction. We'll keep this for now. Maybe my distance down here, I want them chonkier. Some thick boys. Linux over Windows. So I actually have this thing up. So this guy was doing some comparisons with all the different solvers, comparing Windows with Linux. Yeah, and it's a lot faster. It's free in terms of licensing and stuff like that. So if you're setting up a render farm, or if you have extra computers laying around, you can just put Linux on them and it's free. You don't need to give Microsoft more money. Just Side Effects is like a good company I'm a fan of. I'm happy to give licenses to them, pay for them, but Microsoft is, you investigate them. They have these Halloween documents. So they have done like conspiracies and stuff like this in the past to stifle open source software, other initiatives that's like pretty bad business practices. So I just don't like to give Microsoft money, as well as it's just not as good. It's deep into the conspiracy hole there. So we want these guys a little bit thicker. Maybe something closer to that. Linux Mint isn't necessarily good for graphic, like it's not better than others, and it's basically like you don't want to go too wild with your Linux implementation if you're doing visual effects. Like you can get some really like hackery, like kind of, you think I need some Y scale? If you look at like Arch Linux, you can get some like crazy Guccifer, like HackerMan Linux distributions, but like with visual effects, you don't want to get too wild with your libraries. Otherwise, like you run into issues with like the display or whatever. Like Linux Mint is just the easiest to install and set up and maintain as an end user. Like you don't want to waste all your time messing around with Linux libraries and stuff like that under the hood. So these could be pretty good. You think these angles? Which angle do you think isn't the best? The like extrusion of my font? You think that's a little bit, maybe that's a little bit better. I might want some more amplitude of Y, go up to 18, and then just overall maybe more letters. It's a little too many. Maybe my grid, like we want more so that they're going through the walls or expanding or whatever. Maybe let's just get started with something like this and put it in context and see what happens. Whoa, this is a lot bigger than I thought it was. So maybe 10 to scale. That's gonna mess everything up. I'm just gonna go with a transform down here. It's usually not a good idea to nest, like work in a lot of different spaces and stuff like that, but just to speed up this stream, I'm just going to keep going like this. So this is just going to be my final like size. And then do the project again, I think. Maybe you can either do maximum. You might want to try replace, but like you can see some areas it's missing. So if it does miss, what I could do is make another grid that's pretty big and just under everything, like a background kind of. Merge. So now if the height field project doesn't find one of these letters, it will just use this as like the furthest surface. Then we might want to do that blur again. Whoops, this is the wrong one. So we're working with height fields. We need to make sure we're doing the height field blur. That other blur was for like regular geometry. So you could do a super blurry surface and even start to get some of the waves, like the larger scale distortions that they had at the end of that shot. But just to pick up more of these, we're gonna do a little bit sharper of a blur. So just want to smooth some of the artifacts and stuff like that. Yeah, you can animate it over a shot. That'd be pretty cool. So now if we go back to our original setup, we need to replace or figure out a better way to do this distribution of stuff. So we have this height field here that's going to be the ground. We're going to replace it with this height field. We're going to have a new ground here. We also want our height field convert to be updated as well. And then we just need to change the way that we're sourcing particles, so the first frame lines up with the X's or the new shape. So I think I'm just going to take a copy. You hold down the Alt key. You just, whoops. You hold down the Alt properly. You can drag and drop copies of nodes. Yeah, the Ember Gem stuff seems pretty cool. I saw them like simulating 10 million particles on the GPU or something in real time. It doesn't look like they released it yet, but it seems pretty powerful. So what I did is another convert to polygons, go from height field to polygon, and yeah, I saw their announcement videos with the shockwave and stuff. It looked pretty cool. So I'm gonna do another poly extrude here. This one's, you can see these operations are pretty slow to cook, but because it's just sourcing the geometry at the first frame, it will just run once. It should still be pretty inexpensive. And then this time I can do transform extruded front. Instead of local space, I want like just a global world space transform. I'm gonna try to line it up as best as I can with this guide geometry. So I want to go up 1 unit, I think. Something happens. So I also want to scale to 0 so that my new face will be completely flat. I'm just gonna also speed this up so I can do height field resample. And then this resolution scale, I can just downsample my height field. So we're working at 1K. Go the other way. So if I go to 0.25, now I'm at like 256. Now this stuff is more interactive or whatever. So I'm scaling and then I'm moving it. I'm just doing this so that I can line it up. So it looks like 5 units up. It's pretty good. And then I just need to close the back side. And then it's just too big, so I want to crop it to match. I don't know if there's a way to crop. Oh, it looks like there is. So I can try doing that step here. Just need to go way. Ooh. Oh, it gave me an error for a second. So that looks like it's pretty good. And now we're working in the same space there. I can just change the wiring over. We're pretty good. So we're doing stuff with gravity this way. You might want to work differently, but for right now, I'm just gonna let's see what we have. So it looks like our X's are like too high off the ground or something in one area. We need them to be further in this direction, maybe. We might be going the wrong way as well. Maybe I'm doing I don't know, I'm doing too many things and I'm confusing myself here. So let's just give this a try, see what happens. Yeah, with EmberGen, it just seems like a big time investment on my end to learn like another solver, because it's like outside of Houdini. I don't know if I want to invest that time into something that, like, if I get hired for a project, it's another license you have to pay for. It's another, you go to an actual studio, like you need to ask the IT guy there to install it. It can be a little bit of a mess. So I'm just gonna try some different seeds. See if we can get something that fills in that space a little bit better. We might want these. I think it's a little bit disorienting because we're like projecting and transforming spaces and stuff around. We might want these X's to be smaller to match the reference, but we're getting so the stream is getting a bit long, so I'm just gonna keep going pretty quickly. So just gonna play around with this remapping that we're doing to the curvature to try to find like the sharper, I think. I think that attribute transfer got super slow. So with this one, I can kind of play around with the contrast or whatever of the masked area to get different curvature regions. This stuff could be good. Let's see what happens here. So I don't want to do these X forms anymore, because that's going to spin. We're not spinning the collisions anymore, so we don't need to worry about doing them. Let's take a look at it in context with the camera. So it looks like my curvature regions aren't as good, like being flat like that. Looks like we have some missing space as well. But we'll just do a test render, see what happens. So I think I messed up some of my stuff is upside down maybe. let's go back here. So I might be able to quickly fix it. Just do a transform, go 180. Just flip everything. And then I think I need to change this. Just not using the best workflow right now, but quickly hacking things together. So I'm gonna try. It would be better to sort this out properly, I think, and like my gravity should just be one direction only, and I shouldn't be like changing the world orientation so much. Let's give this one a try. So this one's good, how it fell right in the middle. So I think now our wall, maybe that was a mistake. So I think I just had it spun the other way. Something bad is happening. I don't think I want to do that. The height field rotate might mess up. I think it's going to jack up the values and stuff too much. So I think this, something back to closer to where we were. And then I think when I was rotating it to align with like the other part might have been flipped around at a certain point or something. So there's other work to be done, but for right now I think we're close enough to, we got a lot of things going, rotated the wrong direction, but we'll just see what happens here. So I'm just gonna go up to the object level and do a flip book. See what it looks like with our X's moving around. You think they use the velocity to mask the curvature? There's something that they're doing that's a little bit extra that I haven't completely nailed here. So I think they're using the depth, perhaps certain areas they're animating or like pulsing the curvature. They might be doing some stuff with velocity. They might also be like updating the curvature during the simulation so that that value is preserved like frame to frame. It seems like they're doing a lot of different stuff in the different shots. Like this one might be velocity with a noise mask or something. These are definitely more velocity, I would say. But with all the, like, these stuff at the start is just more like raw curvature with a mask, I think, or I don't know. That stuff there is like what I was going for a little bit, but Houdini's great because you can work with attributes like a compositor and like hand animate them, copy them different ways and transition them and everything like that. So it's not, we're not doing that great in terms of matching the reference with this one or any of it. The motion we haven't nailed in very well, but I'm gonna stop finessing things that much right now. Be up too many X's, yeah. So I think just like my size and the rotation of them is they're going the wrong way. Something might be flipped around, but I'm gonna get close to ending it here. It's too long for me to to keep doing this in one session. Maybe we'll I'll save the files if you guys want to improve them and share your results. We have the Discord. There's a link to join the Discord at the bottom underneath the stream window. So if you do end up with something cool or get closer, you try some other stuff. I know, where was it? Corin Yan? He had some better ideas, I think, in terms of they're constrained using different methods in some of the different shots as well, like whether they're laying like this way or flipped around and like riding on top of the surface. So that would be something to play around with dialing in. But overall, it's a pretty good start. Corignan, I tried. That was a good catch with your eye to see that like different constraint methods and stuff like that were used. The pasta machine, that's a good one. Yeah, I've been messing around with that a little bit on my own, and it's a pretty flexible setup. As well, like switching the vellum solver out with grains. I didn't have a chance to try that today, but you might be able to get faster simulations or like quicker results that way. But yeah, I'll put the files up, try out all the different things, make the Xbox color scheme, the Code Red Mountain Dew color scheme. So thanks to all the new viewers and everyone that came over here from Reddit. It's good to get some more activity here. Yeah, so if there isn't any more questions, probably end it. All right, thanks for stopping by, everyone. It seems like there aren't any desperate people going in for a last question. My schedule is on the Twitch stream. I think the next one's gonna be Friday. Usually on Fridays we're doing like a self-contained project in a quicker time period, just like Instagram daily style art or whatever. Should be a fun one. So hopefully see you guys on Friday, end of the week party.